Hello everyone. My name is Mikhail Serkov. I'm delivery manager and high-performance computing engineer in EPAM Systems United States Life Science Department. And today today I'm going to talk about using Zabbix for high-performance computing, monitoring, and support. I've been working for high-performance computing projects for, I think, 7 years. So I'm going to share the experience, and Zabbix, it's a kind of new finding for us. So yeah. Agenda for today, it's only the main points from my presentation, so it's not completely a whole thing. But we'll talk about how high-performance computing in general, what is about in terms of this presentation, overview of the customer's infrastructure. It's about the project we are working on at the moment and where we use Zabbix. High-performance computing monitoring, it's about differences from classic infrastructure monitoring. And then it will be example about how do we use Zabbix and what ideas we have. So in general, it would be more case study presentation than something really technical. First of all, I want to kind of introduce our customer we're working on. It's Novartis Institute for Biomedical Research. It's a pretty huge company. It's a part of Novartis Pharmaceutical, the biggest pharma company, I believe. So what they do, they actually do scientific research in many different areas like bioinformatics, drug discovery, computation chemistry, and a lot more. So it appeared that in all these areas in modern days, scientists need a lot of computation power. So around 10,000 of modern CPU cores is in use for scientific computation research. And so we have offices in different countries, in the United States, Switzerland, in China, Singapore. So we have clusters in every single site, and all these clusters are shared. What means shared? That any user can actually log in and start his experiment, and they do it simultaneously. So sometimes it looks like completely mess because they do it like without deep understanding of IT. They do science, and they don't care if they break something. So we actually manage support for HPC, and we take care about clusters up and running, and they do it efficiently. What they doing in general, it's they run different scientific tools. We have around 500 different tools on the cluster. And also they do their own in-house development using Python, Java, R in common, but sometimes it's Fortran, C, and so we actually don't know what they run until we look deeply inside. So high-performance computing. I just want to do a brief overview because then you say cluster, people just think about some modern things like, Spark, MapReduce, Hadoop, Amazon Web Services, and all of this. But when we talk about high-performance computing in pharma companies, it's mostly about classic high-performance computing like batch queuing system. And actually, it's simple. We have a lot of Linux boxes, and they just want to run shell scripts on them. So it's nothing, no magic. It's not a black box, not easy button, and just a lot of Linux boxes. Very powerful, but anyway. So we have hundreds of hosts and sometimes thousands if they go to cloud and use cloud power for computation. We have grid scheduler, and it's a core thing of high-performance computing. It's usually Sun Grid Engine or forks like Univa Grid Engine, PBS, and so on. It's a lot of them, but in general, it's like batch computing grid scheduler. So they do massive parallel computation across the nodes. Sometimes they use OpenMPI and some jobs uses like thousands of CPU cores simultaneously. So it's kind of hard to trace who uses what at this moment. And also it's a very, very strong requirements to all infrastructure groups, because if you have a storage a little bit slow, degrading because of some node is unavailable, it's kind of okay for regular infrastructure, but it's a disaster for HPC, because if you have 10,000 cores accessing to storage which is operates slow, it might completely destroy all HPC infrastructure in minutes. So this is example how actually scientists do. They submit their job, they just run some kind of Linux command liner, and in this case it says that, okay, I want 10 CPU cores, 4 gigs RAM per each core for 1 hour. I want Lustre file system mounted and 2 GPU cards, and I just want to run workflow SH script on the resources. And then scheduler just choose the node, reserve these resources, and user go into. Yeah, this is kind of overview of the customer infrastructure. Actually, it's not really good picture, but unfortunately, I'm not allowed to provide complete infrastructure diagram of Novartis high-performance computing because of NDAs, and it should be approved. So it's best what I have. And actually, what I want to emphasize is that it's all bare metal. So we're talking about hardware. It's not, we mostly don't use cloud, Amazon Web Services or Azure. It's all data center, big bare metal boxes. So we have InfiniBand everywhere. We have Lustre file system, 1 petabyte, I believe. And also it's not here, but we have around 40 petabytes of parallel NFS storage connected by 10 GB links to every single node. So it's a diagram of one of the cluster from the United States. We have 250 GPUs there, and it's really impressive from power consumption point of view, because after latest upgrade we got some problems with power supplies in data center. Literally power, circuit breakers was pop up in progress of computation. About 70 terabytes of RAM, so yeah, it's pretty huge. And in this cluster we have around 7,000 of CPU cores. This is typical computation node configuration. So we have on every single Linux box we have 28 cores, 200 GB of RAM, 10 GB Ethernet, InfiniBand, GPU card, 8 GPU cores, NFS mounted to 10 GB link, and Lustre over InfiniBand. So, yeah, software stack, it's not all software we have, but base operating system is Red Hat Linux, and not the latest one, 6.7, because we can't upgrade, often. It's a big mess in pharmaceutical company to do all the change management. They're really restrictive. So, as a scheduler, we have Univa Grid Engine, and as a monitoring system, we have Zabbix 2.4, not the latest because of same reason, but it's really impressive how Zabbix fits well in this infrastructure. That's why I'm here, because it's really interesting use case we have here. Yeah, so differences between HPC monitoring and monitoring of, classic IT infrastructure. So as we allow users to run something on production servers, which is not usual thing in general, we need not only metrics about how loaded is server or how many RAM it's in use, we actually need who, when, what is running on the server, what was running 1 hour ago, for how long, which CPU cores it was using, and so on. And especially who was it, because most problems, like 99% of problems, it's actually users. It's not hardware or infrastructure, its users, because they run something strange. So 100% CPU utilization and RAM utilization is perfectly fine. It means that everything works fine. So we have no such checks like, oh my God, load average is more than 0.8, something is wrong. No, 100% is perfect. Node crash is not a big deal. It's true because, I mean, we have a lot of nodes, and if 1 or 2 or even 10 goes down, it's not a good thing, but it's not a disaster. So we mostly interested of understanding why it goes down. So we need Zabbix as a tool for analyzing what was before it goes down, who was it, when. So if you look on our dashboard, it looks messy because, okay, we have 3 or 4 nodes down for some different reasons, a lot of warnings about, okay, someone uses swap a lot or something like that, but it's normal. So failure is normal for our infrastructure, which is kind of strange for regularity, because if you have like mail server down, it's a disaster. For us, node down, who cares? We use aggregated metrics a lot. So if you just do average CPU utilization for like all your infrastructure servers, mail server, database server, web server, it doesn't make any sense. For us, it's only what makes sense, because we aggregate utilization from all computation nodes, and we read this like a book. It's actually, we have aggregated graphs I'll show you a little bit later. And you can actually understand what's going on by just looking at the graph. So most of the time we use Zabbix not in the dashboard, but in screens. We have a lot of different screens for understanding issues. And also huge things. Metrics we use not only for understanding if we have a problem, but we also use it for performance analysis. One of our goals is actually performance. So we not only keep a cluster up and running, but we help business to make their research faster. And it appears that from IT point of view, it's kind of easy to increase performance by just using system level tuning, like, okay, you need to increase the limit of memory, or you need to switch to different file system. Sometimes it provides you a lot of performance, like twice faster, 3 times faster, even if you don't look into the code. And the last one thing, so we actually provide access to users, for users to our monitoring system, because they want to know what is going on the cluster, what's going on the computation node they're running some job. They actually want to see what's going on. They want to know pending time, cluster utilization. If they, what would be pending time for their job, then they submit. And Zabbix actually fits really well because of GUI, and it's perfect, it's easy, it's transparent, so our users are really happy to have this access. However, we restricted this access, and I'll show you a little bit later how we did it, because it's kind of tricky. So why Zabbix? When we came to Novartis like 2 years ago, they didn't have monitoring at all. So they had Ganglia, not really well configured, and they have some native grid engine monitoring tools which only show you like node is down or not, or it may be overloaded. But that was all. And we started to search what can we use for monitoring. Initially, we tried Nagios because, you know, we wanted something really fast to get this project. So we started with Nagios for a few weeks. It's kind of perfect product, but not fit well for this situation. And then my colleague, who unfortunately couldn't be able to attend, his name is Nikolai Radionov, suggested to use Zabbix, and actually we didn't expect at the start how perfectly well it will fit. So we made a demo and showed to our customers. They said, well, yeah, we can try it. And after a few weeks, after a month maybe, we understood that actually using Zabbix for HPC monitoring improves quality of our service significantly. So we actually started to predict issues. We started to help users until they have issues. So now we kind of have proactive monitoring. We contact users even before they understand that something is wrong, because we see it on graphs and we tell them, okay, we can improve. And it's kind of impressive. So most points, why Zabbix? So it's able to monitor huge systems with a lot of metrics. So after yesterday's party, I talked with a few folks from here, and I wanted to remove this huge word from the presentation, because I understood that it's not huge. We have like maybe 700 hosts with maybe 200,000 items in general. And it's not huge. I know that someone from here has like 10,000 hosts and about 1 million of items. So we're not huge. However, HPC, especially in pharma companies, it's raising really fast. So for last year, our performance capacity doubles. And we kind of tried to estimate requirements, and it should triple next 2 years. So yeah, I mean, after a few years, we will be something that they can call huge, and we don't actually want to redo all the work. It's flexible, so templates and host groups is perfect, and this thing from 3.2 with nested host group, I think it fits really well to us. Ability to aggregate metrics out of the box, it's kind of essential thing for us, because we don't really want to, invent the wheel and aggregate all the metrics by ourselves, so it's essential thing. API, yep, because we extract data to data analysis tools and kind of trying to play with all metrics, trying to find the relations between users and utilization, who use more. So we use Zabbix as actually data storage, data collector. When we extract data, we need to store for like a long and analyze it. GUI is perfect, and auto-discovery and new nodes automatic configuration also works for us really great, because when we have like new rack of nodes, we just enable them, they execute, got agent, and they appear in Zabbix. We don't actually need to do anything. And for HP, we don't need to configure them, because we have like standard configurations. They all in there. This is kind of what we have. So as I said, we're not huge. And it's also was the point, because our customer kind of was worried about, okay, Zabbix is great, but we need a database, we need like separate server, maybe a few of them. So it appears that we can use only one of our old computation node to, at least at this moment, it covers all of our needs. So we have 20 CPU cores, server, 120 GB of RAM, which actually used for database. So 600 hosts. It's not all of them, probably it's a little bit outdated info, but maybe at this moment we have something around 800s, but it's not a big deal. And database size is 180 gigs. So that's what we have. And what and how do we monitor? So I split it to local metrics and global metrics. Local metrics is what we monitor on the hosts. And of course, we have all Linux default metrics from template, like CPU utilization, RAM utilization, and everything. But we also monitor every single GPU and CPU core. We have auto-discovery rules for them, because we actually need to know utilization by core. In modern grid engine technologies, software, we can actually bind job on the core and say, okay, I want to have 6 cores, 3 cores on first circuit and 3 cores on second circuit, and I want to use this NUMA node connected to this core. So we have to understand what core, how every single CPU core utilized, and same for GPU. We monitor NFS shares availability. It's a kind of essential thing, and also utilization of NFS shares, I mean IOPS. All these metrics came from agent, so we don't use SNMP, we use only agent. And also we monitor all the things coming from scheduler. So we have a lot of external scripts which gets data from scheduler and put it on the host level. Then we aggregate it in global metrics. So we have something we call meta CPU utilization. It's actually aggregation of CPU on all the nodes. NFS global transmit, retransmit thing is kind of very useful for storage team, because you can actually predict an outage. If you look on the graphic, I'll show you a little bit later, it will look like a small spike, then one of the nodes start degrading, for example. And at this moment, we just disable the queue on HPC, because we know that after a while, it would be disaster if it don't stop. And it helps our storage team also to react very fast, because they don't have such a matrix. They didn't have it before, they have it now, and they can operate more efficiently. So grid specific is like everything about slots, running jobs, pending jobs, and all of it, all things in terms of whole cluster, not node. CPU memory oversubscription, it's a kind of interesting thing, because we can actually, we do know what is CPU utilization supposed to be on computation node, because the user, when he submits job, he says, okay, I want 10 cores. It means that we should, on 20 cores node, for example, we should have load average 0.5. If we have more or less, it means that something is wrong. So we can actually understand if node is oversubscribed or undersubscribed. So that's why we have overloaded nodes, and pending time is also important thing. This kind of examples. So I already mentioned expected utilization is real utilization. So yeah, we actually know what's utilization, and if it doesn't match well, we actually contact to scientist and tries to understand why his workflow doesn't use like 10 cores. Instead of that, it uses like 5 cores. Probably he needs to tune something, some parameters, or it oversubscribes, and it's a kind of dangerous thing, because if user requests 1 core and runs on 10 cores, it's not a good thing. Scheduler doesn't know anything about how, in real, how many cores user uses. Users on computation node. So it's a kind of part of spy games. So we actually allow users to log in directly to nodes to debug their jobs, or review some intermediate data. But sometimes new guys or sneaky guys, they just go to the node. They don't want to wait in pending list, and they just think, okay, I'll run this directly without any scheduling for like hour. Nobody cares, but actually we care, because it might cause node crash. So we have a check like suspicious users. And sometimes we just send them screenshots, and actually we stopped do this. So pending time, it's a very important metric for our users and for our managers actually. And we cannot actually estimate pending time because it's not first in, first out or something like that. Pending time really relies on resource request. So we actually configure Zabbix to do probes of using schedulers. So Zabbix submits jobs with different resource requirements and kind of checks how long does it take to run it. So we have this graph. And by viewing this graph, user can actually understand like what weather is today. It's not exactly I'll wait for like 8 minutes for this job, but it's kind of I'll wait for like 8 or 10 minutes or something like that. And for managers, it's a perfect metric to go to their managers and say, okay, we need expansions, we need like new hardware because we're too tight. So this is kind of examples of what we look on every day, every like 10 minutes, because it's actually a book of the cluster. We, by using these graphs, this one and some of below, we can actually understand what's going on, who is running what. So, for instance, this is an aggregation of all CPUs in the cluster, and red one is used slots, green one is kind of active slots, yellow one is inactive slots, maybe hosts in the maintenance or they down or something like that. So if these values start spiking, we kind of understand that something is wrong without like looking into dashboard or something like that. And even on this graph, we kind of see that we have like green line above the red one. It means that for some reason, all CPU cores is not utilized. So we have to go and check why. In this case, they're just reserved, but in general, we kind of have to check why they're not in use. And this table above, so we have some kind of annotation to every single graph. For this graphic, it's about top 5 users running on the cluster at the moment. And it was kind of trick for us because some of our external script returns arrays actually, and Zabbix doesn't support well arrays. So we actually return it like text, and inside the text we put HTML tags. So then we do put latest data into the screen. We'll get pretty nice view. I know it's a kind of not really efficient to do it this way, but at least it works and it provides us a nice view to look on. This is a perfect example of how we use Zabbix and how can we prevent some issues. So the same as CPU, we can predict how many RAM actually is in use. And red thing is how many RAM reserved. The yellow thing, how many RAM actually in use. And if these values are too different, we have to like check who was it. So someone just says, okay, I need 10 GB of RAM, but use only 1. It's not a good thing because other users waiting in the queue, they don't have enough RAM to start. This is kind of essential thing for us. And inside of Zabbix, without logging into any Linux node, we can tell that, okay, it's probably this user because he started his jobs like 10 minutes ago, and after that graphic is raises. So we don't need to go anything. We have everything in one place, and it's really impressive. Same thing for CPU time. So red thing is CPU time reserved. Green, it's actual user time on the node. And yellow one is a summary, including disk weights and system time. So here we can see if someone ran his workflow not efficiently or he oversubscribes cluster or something like that. So we actually can see this little round thing when we see some fluctuation, we actually go and check why CPU utilization is so different. And in some cases, we found the user who just used his workflow not well, and we can help him to improve the performance. Yeah, actually, this is kind of one of the most popular view of the cluster. It's meta-utilization graph. For instance, here you can see the yellow thing. It's disk weights aggregated on whole cluster. So if you see, like, it doesn't seem so big. It's like 10%, maybe 15% of disk weights. But in terms of the cluster, this 15% of disk weights means that around 1,000 cores just waiting for disk operation. So we have 1,000 modern CPU cores do nothing. And it's a kind of signal for us that we go and investigate who was it, why. Probably he need to switch to different file system. Yeah, here's a perfect example of disaster, actually. So it's a kind of graphic of cluster status, aggregated cluster status. So green is a good guys. It's a node which is active. Yellow is total nodes, and red line is overloaded nodes. So some guy just submitted a job which requests 1 core, but supposed to use 10. And cluster was free, and he submits like 1,000 jobs. So in like 20 minutes, whole cluster was overloaded completely. And if you go at the same moment into the dashboard, everything is fine. So hosts are pingable, everything is accessible, nothing to worry about. But if you actually go to Node, you will see a lot of processes which just fighting for CPUs. So when we see such a situation, we block the queue and contact users. The funny thing is that we're not allowed to actually delete the job because it might cause data loss or something like that. So we actually contact the users, and sooner we contact him, sooner we can resolve this problem. Yeah, this graph we use for kind of talking with our storage team because they don't believe us every time, so we have to have some proof. And this is what I talked about like 10 minutes ago maybe, some small spike in retransmits. And it means nothing. Shares available, everything works perfect, but some tiny little spike, which means probably one of NFS cluster node failed for some reason. Maybe disk outage, maybe something like that. So after an hour and a half, we got serious outage, very, very serious, which caused complete outage for a cluster for 2 days because NFS storage just went to unavailable state. For some reason, they had failed nodes everywhere. And after an investigation, we found that actually this first spike was a kind of first sign, and then some of our users started to hit NFS storage. Something went wrong, and we got like retransmit in the sky. So when we see such picture now, we can disable node and prevent this global outage. So we disable nodes and ask storage team to check. And actually, it increased quality of service for our team and for storage team. So we kind of integrated well. Okay, okay. Yeah, I think we can. This thing, I think we can skip because it's kind of very, not very specific things. This is how we patched Zabbix interface. So we actually removed everything for West users. They only allowed to see screens, only few of them. it's the only patch we have. It's a kind of not really good solution, but it's the only way to do that. This is overview of benefits, and our customer is pretty happy to have Zabbix. So we kind of increasing performance of scientists, and we're increasing performance of workflows, which wasn't expected when we started to use Zabbix. It was like just a monitoring system. So, yeah. This is kind of ideas. We want to like integrate Zabbix with HPC cluster because we have an ability to run kind of scripts from within the job context, and we can do job profiling from automatically. So if user want to understand what actually he is using, we can do a snapshot from Zabbix. Yeah, I'm sorry, I'm a little bit short of time. Yeah, so if you have like any questions.
How do you collect data about jobs distributed among different nodes?
Sorry, could you please speak to the microphone? Thank you.
Hello. Okay, how do you collect information about a job distributed across different nodes, but belonging to the same user to set a single picture, well, a single graph of this user?
So we're collecting this data from actually scheduler, because scheduler knows about when where job is running on which nodes, but obviously we can't display it in one graph. So that's what we kind of want to do now. If user runs job on the same node, it's okay, but if it's on the different nodes, we have to collect this data on the fly using API. So at this moment, it's not kind of implemented.
So essentially, you don't collect something like, well, job profile with CPU usage, RAM usage, everything else related to this job for future analysis.
Yeah, that's what was on what's next. We want to have it implemented using API, but you know, low time, short time.
Okay, any more questions? So I think that there is no more questions. Thank you very much, Mikhail.
Thank you.